Hello everyone. In this video, we'll be discussing about the normal distribution. We'll see the different properties of normal distribution, and at the end, we'll also see the standard normal distribution. Moving ahead, here we have a histogram. If you don't know what a histogram is simply the most commonly used graph to show the frequency distribution. On the x-axis, we have the data points, and on the y-axis, we have the frequency for the data points. So the point or the bin with the highest peak has the highest frequency. So if we draw a smooth curve to represent this histogram, we get a bell-shaped curve, and we call this bell-shaped curve as the normal distribution or the Gaussian distribution. Under the measures of central tendency, we have seen three terms, that is mean, median, and mode. Let us locate each of them on this graph. For the mode, we already know that the point or the data value which has the highest frequency is called the mode. So from this graph, I can clearly say that this data point has the highest frequency. So this will be my mode, or simply the peak of the normal distribution or the peak of the bell will represent mode. Moving to median, we know that the center point of the distribution or the middle value is called the median. Again, we'll see that among these data points, this is my middle value. So this will be my median. I can see that my graph is symmetric. So my mean will also lie on the center point. So I have all three values, mean, median, and mode, on the center point of the bell. Under the measures of variability, we have seen that if my standard deviation value is less, we get a steep curve. But if my standard deviation value is large, we get a flat curve. So we can use standard deviation as well to represent the normal distribution. In simple words, normal distribution is a probability density function which is a Gaussian distribution of mean and standard deviation and is represented by a bell-shaped curve. Moving ahead, now we'll see the properties of a normal distribution. Here we have the formula which represents the Gaussian or normal distribution. In this formula, we can see that sigma is standard deviation and mu is mean. So we can clearly say that normal distribution is a function of standard deviation and mean. We have already seen that for a normal distribution, mean, median, and mode are equal. For a normal distribution, the curve is symmetric, or we can say the curve is symmetric with half of the values on the left and other half of the values on the right of the mean. As we know that the normal distribution is a probability density function, so the area under the curve is equal to 1, which is a property of every probability density function. For normal distribution, the value of skewness is equal to 0 and kurtosis is equal to 3. We will see about skewness and kurtosis in the upcoming videos. Another very important property of normal distribution is that a normal distribution follows empirical rule. Now let us see what empirical rule states. As per the empirical rule, for a normal distribution, 68% of the data will fall within one standard deviation of the mean. 95% of the data will fall within 2 standard deviations of the mean, while the 99.7% of the data will fall within 3 standard deviation of the mean. Therefore, empirical rule is also known as 68, 95, 99.7% rule. Therefore, from the below distribution, we can say that 68% of the data will fall within the region of mu minus 1 sigma to mu plus 1 sigma. That is, in this region, I'll be having 68% of the data points. Similarly, 95% of the data points will be present within 2 standard deviations of the mean, that is, from mu minus 2 sigma to mu plus 2 sigma. I'll be having 95% of the data points. And 99.7% of the data points will be present within 3 standard deviation of the mean, that is, from mu minus 3 sigma to mu plus 3 sigma, that is, in this region. We have seen that a normal distribution can be represented as a function of mean and standard deviation. If I keep the standard deviation same and take different value for mean, I get the same shaped normal distribution but centered at different points. So this is how normal distribution depends upon mean. Now, if I keep the value of mean constant and take different values of standard deviation, I'll get two different shaped curves centered at the same point. We already know that if the value of standard deviation is small, we get a steep curve. But if the value of standard deviation is large, we get a flat curve. So this is how the shape of the bell or the shape of the normal distribution depends upon the standard deviation. Coming to the standard normal distribution. A standard normal distribution follows all the properties of normal distribution. Apart from that, it has few other specifications. For standard normal distribution, the value of mean is equal to 0, or we can say that it is centered at origin. For standard normal distribution, the value of standard deviation is equal to 1. Again, just like a normal distribution, we have mean equals to median equals to mode for standard normal distribution. The value of skewness is equal to 0 and kurtosis is 3. Only thing that you need to remember is, for standard normal distribution, the value of mean is equal to 0 and standard deviation is equal to 1. I hope you liked the video. Please subscribe the channel if you have not already subscribed. Thanks for watching.